Part C of our translations for parabolas. Remember that a translation was a movement left, right, up, or down. Now we're going to take a look at this next one and see what it relates to. So let's say I have the base parabola again. Remember, it's y equals x squared. So we have the following numbers for our x squared term. And we have our base graph, which looks like this. Now, if I'm looking at this equation, y equals x squared, that is what my points are. So if you think about this new equation that we have here is we're taking the y value and we still have our x squared value, but we're going to be adding this little extra bit here. Okay? So what happens is our 9 turns into 9 plus 2, which is 11. And then our 4 becomes 6, and our 3 becomes, our 1 becomes 3, our 0 becomes 2, because we add 2 to it, and we do the same for each of these. So if you think about it, this means just add 2 to everything that's in the first column. So now, let's continue. So we end up with 3 again, 6, and 11. And now, let's graph that. So, like I said, if you think about it, visually what's happened is we've literally taken our graph and literally shifted it up by 2 points. Shifted each of those y values up by 2 points. So now let's take a look at the last graph, y equals x squared plus 4. If we're using the same concept that we did before, we're just adding 4 to basically so now if you think about it, what we've literally done is we've added 2 to our original graph, y equals x squared. And what that allows us to do is it allows us to think of our x squared as being literally pushed up to our new vertex point being at 0, 2. So all of the points in our graph have shifted up by 2. So now let's go on to look at the last equation here. The last equation is y equals x squared, and I'm going to use black, x squared plus 4. So think of it this way. We had, so the first variable here, we had the first set of values here, we had 9. So we have 9 plus 4, which gives us 13. And so we add 4 to each of these values that we have for our x squared term. So 4 becomes 8, and then 1 becomes 5, and then 0 becomes 4, and then we have 5 again, 8, and 13. So now let's go and graph this. And so now what we have to do is we have to think of x squared as being shifted up to its new base point of 0, 4. So basically all of the points in our graph have been shifted up to that value there. So all of the points from the blue graph have been shifted up exactly 4 units, exactly as we expect. So what's happening when we have y equals x squared plus k? What literally happens is this. Our graph literally moves up k units. So it translates up k units. So if it's positive k, it moves up k units. And we're going to do the same thing for our last set of numbers, and we will see what our values are. I will go through them in like 2 minutes. So we have our base graph, y is equal to x squared. And now what we'll do is we'll do the same thing again, but now what we did in our last graph was we said, okay, so imagine we're going from this graph to this graph. All we've essentially done is taken away 1 from our graph. So we have x squared minus 1. So that means 9 becomes 8, 4 becomes 3, 1 becomes 0, 0 becomes negative 1, 1 minus 1 is 0, 4 minus 1 is 3, and then 8 again. And that gives us a graph that looks like this. So what we have is y equals x squared, and then because we've literally subtracted 1 from each one of the points, basically all of the points literally just shift down exactly 1 point. So we've actually shifted the entire graph down by 1. And we would call that y is equal to x squared minus 1. So now let's do this for the last graph. So remember, we took away 1 from here. So now let's go and do the same for our last graph of the day. So now this is x squared, but it's minus 3. So we're actually taking 3 from the basic image of x squared. So 9 becomes 6, and 4 minus 3 is 1, and 1 minus 3 is minus 2, 0 minus 3 is minus 3, 1 minus 2, 3 is minus 2, 4 minus 1 is 1, and 9 minus 3 is 6. And now we get this graph. Now recall, all we did was literally take away 3 from the x squared y value. So essentially, if we look at our graph, imagine we start with x squared, right? Every single one of those points would literally just be shifted down by 3 values. And so now that we're here, that's what our graph would be. Now, what I want you to do is I want you to take a look at these 2 problems. Now, your final challenge will be, tell me, what exactly happens when we have x squared plus 8, and what exactly happens when we have x squared minus 9? You must use the word translate to refer to either moving up or down. Okay, so pause the video, tell me what it looks like. So when it's x squared plus 8, we're saying that the graph of x squared just translates up 8 units. Now let's take a look at x squared minus 9 based on what we just studied. So that means this will, pause it, try it out, and we end up translating down 9 units. So what does this mean? So for our basic graph, y equals x squared plus k. If k is negative, it moves down. If k is positive, it moves up. Let's go over what we just studied. So we're taking a look at the equation y equals x squared plus k for the basic graph x squared. So technically what's happening is we have a graph that's either opening up or down, but for this case we're just going to assume it's opening up. Now, here is what happens. If k is positive, we noticed that our graph would be just a carbon copy of our y equals x squared graph, but what would happen is the graph would move up. So essentially what happens is our graph of y equals x squared, a carbon copy of it is actually made, but what's going on is it translates up k units. So now let's take a look at what happens if k is negative. So an example of that would be, well, if k is negative, imagine I had k x squared minus 1. So what would happen is our graph would be a carbon copy of our y equals x squared graph, but it would be shifted down k units. So we would say y equals x squared translates down k units. Now, an example of the first graph would be a new graph, y equals x squared plus 1. And what you would say is the new graph is x squared, but it's translated up 1 unit. This one here, where we're moving, where it's negative, if we had y is equal to x squared minus 2, what this tells us is our graph translates down 2 units. It shifts down 2 units, and we're done. Now what I'd like you to do is I'd like you to work on the task for this specific video.